In section 1.3, we're going to focus on measuring some segments, finding their length both numerically and then with a little bit of algebra. So first of all, we're just going to deal with a line segment here. And we're on a number line, and we're just going to be looking for the distance between 2 points. Now, when we want the distance between 2 points, those 2 points are listed, like on this first one, AC, with absolutely nothing above them. That means give the length. This means segment. This means line. This means ray. Nothing over the top means how long is it. Now, the easiest way to do that is to just count the spaces, not the tick marks. Because if you count the tick marks, sometimes, for example, from A to C, you might go, oh, 1, 2, 3. But we count the spaces, like here in blue, 1 space, 2 spaces. It's the easiest way to do it when it's on the number line. That's not what a textbook would teach you, but honestly, it's the most common sense way to do it. So the distance from F to B, I'll count the spaces from F to B. 1, 2, 3, 4, done. And then from A to H is the whole way, which honestly, too, you might say, well, the root from -5 to 2, I know that's 7 units. Well, then just put a 7 on there, right? I don't really care. 1.1 number, it's easy. Now, we're also going to be using something called the segment addition postulate. Basically, it says kind of like this. If this is Rogers, and if this is Elk River, and if this is Zimmerman. Suppose it's 5 miles from Rogers to Elk River and 10 miles from Elk River to Zimmerman. Well, then obviously the whole way would be 15 miles. And that's really what the segment addition postulate says. It says that when we take one piece, A to B, add to it the next piece from B to C, we get the whole way from A to C. And we're going to be abbreviating this, especially in chapter 2, we're going to be calling it SAP, for segment addition postulate. So it can be done again with numbers, or more importantly, we're going to be doing it with algebra. All right, so I'm going to have you pause the video and try these little practices, okay? And then come back to the video. So now that you're back, remember HK with nothing over it means how long is it from H to K? You can count the spaces, or you can just see that it's 8 to get from -6 up to 2. Or if you're a space counter, you go 1, 2, 3, 4, 5, 6, 7, 8 spaces. You do you, boo, for those. And I think you get that. So let's go on to this next one. The length from P to Q in red here is 4. Now be careful, because this says the length from P to R is 15. So be careful that they gave you the whole way. So the question is, what's this missing piece? Well, 4 plus what equals 15? And the answer to that is 11. Or you could say 15 minus the 4, either way. So be careful whether, because a lot of kids will just go, oh, 19 is the whole way, because they just add these up. Well, you got to be careful, because this P to R is the entire length of that. All right, now let's add a little algebra. So it says point U is on line segment TV. So here we go. I'm going to draw my line segment from T to V. Point U is on it, so I'll put U on there, just anywhere. So before you ask any questions with your homework too, make sure you've drawn the picture before you raise your hand to get some help. So this says from T to V, that's the whole way, guys. T to V is x plus 10. From T to U is 3x minus 8. And from U to V is 10. Well, the two pieces add up to the whole way, according to our segment addition postulate. So the short length, 3x minus 8, plus the longer length, 10, is equal to the entire length. Now, this is why we did some algebra review, because now we have to know how to solve this. So we have some like terms right here over on the left-hand side that we will combine. So we practiced our combining like terms. Now we have an equation to solve where the variable is on both sides. So remember, we also reviewed that last week, that we need to get it on one side. And it's easiest if we move or do the opposite of the smaller ones. So 1x is less than 3x's. So I'm trying to avoid some negatives here by moving that 1x over by subtracting. Okay, now I have a two-step equation. To get rid of add 2, I subtract 2, and I'll get 2x is equal to 8. And to undo the multiplication here, I divide by 2, getting x equals 8 divided by 2, which is 4. Maybe we should try checking it. Let's go try it. Let's put a 4 in for our x. We would have 3 times 4 is 12 minus 8, which is 4. So this length right here is 4. This one's 10. And look at the whole way across, 14. So it all works out. Easy peasy mac and cheesy. So again, I would have you pause this video and you go try this one on your own, remembering to draw that picture first. All right, so now we have point F on segment EG. So the endpoints are E and G. F is somewhere on it. Doesn't matter where, just plop an F on there. From F to G, so make sure I'm labeling that correctly. F to G is 5x plus 1. There we go. E to G, well, that's the whole way across, so I like to go like this. E to G is 5x plus 7. E to F is 2x minus 2. And our segment addition postulate says that the two pieces add up to the whole way across. So that's what I'm going to do. I'm going to travel along that line segment and say, well, this piece, 2x minus 2, plus the next piece, 5x plus 1, has to equal the whole way across, which was 5x plus 7. And now we pass the ball off to a little algebra with some combining of like terms over here on the left. And a negative 2 plus 1 is a minus 1. Now we've got that variable on both sides, but there's fewer over here. They are positive. So we will do the opposite and subtract. We'll end up with 2 x's on the left equaling 7 on the right. On the x attack, get rid of subtract 1 by doing the opposite. Get rid of multiplying by 2 by doing the opposite, dividing, and we get a 4 again. All answers are 4 today. Just kidding. All right. So this says, what if we have a midpoint? Okay, so this just said F is on the line segment. It didn't say F was in the middle. If it's in the middle, we have a little bit different situation here. So what if we have a midpoint? Well, then we know that the two pieces, what do I mean by pieces? This piece and this piece are congruent or equal. Okay, so sometimes the kids will raise their hand for one like this because they'll say K to L is 8x minus 5. And I've taught you have to draw the picture, you have to label it. And L to M is 6x plus 3. And they're like, LaRude, they did not tell me what this adds up to. They didn't tell me the whole way across. It's because they didn't have to. Because if L is the midpoint, then these two are equal to each other. So to solve it, we don't need to add up to anything. We set them equal if we have a midpoint. So now again, we have that variable on both sides. We grab that smaller amount, the 6, and we do the opposite, which would be because it is positive, we shall subtract to get rid of it. We have 2x minus 5 equaling 3. We're going to get 4 again. 2x equals, that's kind of funny. I just happen to have 3 examples where the answer is 4. But be careful. Because if you're doing delta math for this section and you go type in a 4, it's going to give you a red X because it didn't say to find X. It said to find the length of the whole way across. Well, if 4 is correct, then when I put it in to 8x minus 5, and if I put it in here, they're going to be the same. Assuming I did my arithmetic correct, or my algebra. Well, 8 times 4 minus 5 is 27. 6 times 4 plus 3 is 27. Well, they better be the same because L was said to be a midpoint. So what's the whole way across? Two 27s make a 54. So the answer to what is the length of KM is 54. So again, be careful if you know you have a midpoint. We do not need to know this whole length across because we can just set those two pieces equal. All right, so now a little bit of vocabulary. Congruent segments have the same length. And the symbol is in equals with a squiggle over it because it's really, they are equal in measure and their lengths are the same. So segment congruence is showed with little dashes. So obviously if you have numbers on here, you're like, well, those two have the same length. But if there's no actual numbers on it and you see the same number of dashes, we know those have the same length. Now watch how we write that. We would say segment AB is congruent to segment CD. Okay, the same number of dashes means that the segments are congruent. What that also means is the length from A to B equals the length from C to D. Those are really, really similar statements. Okay, but if you're asked to use a congruence statement, then you have to say the segments are congruent. Their measures are equal. So again, this has a single dash. Now, if this one had a triple, then it means it's not the same measure as any of those up there, but they both had a single. So I want you to write the congruence right here. So pause the video. You would say segment EF, boom, is congruent to segment HG or GH. We talked about that in the last lesson, that the order does not matter for segments. And lastly, this word, a little bit of vocabulary before we wrap up this section. To bisect something means to cut it, in half basically, or into two equal or congruent lengths. Okay, so let's say two equal pieces. We can bisect segments, cut it right through the middle. Bam, I just bisected it. If this was 5, this would be 5. We can also bisect angles. So if I had a 40-degree angle here and I bisect it, I would cut it into two equal pieces. So bisect means to cut into two equal pieces. So your homework for this section is Delta Math, and you'll be showing your work on a separate sheet of paper. So because there's quite a bit of algebra in our segment addition postulate stuff, we'll need some work shown for that. So have a good one.